Now we can talk about the other algorithm, the simulated annealing. The simulated annealing. The idea is like we capture the idea of when we use in material science. This one is about the in the like how to build the metal from the mold. So what in Thai is lõmเหล็ก annealing. Oh, how different and how can we apply the idea? So at first, for the simulated annealing, we try to solve the problems of local maximum. We have to allow the problems that it caused the local maximum is uh, you we don't allow it to move down. We don't allow it to move down the hill. So now we will have the probability. We will have the probability, some probability relating to two terms, the times and temperature. So it is like this. Maybe or you can change the times like make it like this or like this, like leave it colder and colder. So when you use in the annealing process, so if you make it like if the temperature decreased too fast, if it is in this case, the temperature decrease fast, like you will get not so good quality of the metal. Okay. In this case, for example, I use like for iron, so maybe it will get you will get the one that is not in a good quality. So the best is try to make it try to make the temperature decrease slowly. Okay, so you will have the function. You will have the function of t. So it will be like to get the t from ft. Okay, so in this case, t is a temperature. So the probability, the idea of probability is the difference from hill climbing is from the current node, from hill climbing. From hill climbing, you have to generate all nodes from the current one, right? And then you have to choose the best one. But for simulated annealing, or say, same, you have to generate all nodes and then randomly choose one. Okay, if the chosen one is better than current, then set current to the chosen one. Okay, so that's all. If not, if not, otherwise, the current will be the chosen one according to the probability by the probability of e power delta e by t, and delta e is h of n minus h of current, where n is the node that you choose, randomly choose. So in the case that it's not better, it means that your probability is, because this is minus, right? So it will be like, you can think that it is the, because delta E is less than 0, right? Because it's worse than. If it's better, you can choose, you can go. But if it's worse, you have to find the probability of 1 by e power absolute of delta E by t. If the values is too high, like you are at, for example, you are at some state like this, and for example, you choose this one. Delta E is very high. So if delta E is very high, what is it? It means that this one is high, so E is natural number. So this value is very high. So if it is high, so probably it's very, very low. So you won't jump off the cliff, of course, because if delta E is high, the probability will be very low, right? And if 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 in the case that temperature is high, if temperature is high, in the case that temperature is high, this one will be very low. And if it is low, this is low, and the probability is high. So in the case that temperature is still high, can you remember our graph? It means that in this period, if you randomly choose the worst one, you will set the next state to be the current one, and then move on. So it can be like, it can move out from the local maximum one. What is the local maximum? Because in that idea, so if you are at like the first few stage of searching in simulated annealing, you can move down the hill, right? And if you randomly choose, and okay, if it's better if you move up and then move down, 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 and according to the probability until the times is higher. For the time is higher, the temperature will be lower. So if you randomly choose, but you choose the worst one, so at the time, like the final stage of this search, if you randomly choose and it's not better, it won't go, because now the temperature is low. So if the temperature is low, it means that it will be, the probability will be lower. So in the last few steps, it will like move up, 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 because it controlled by the temperature. Okay, so for the simulated annealing, now you can like solve the problems of the local maximum in hill climbing. Okay, so I hope that you can get the idea how can we solve and why do we use this probability. See you in the next video clip with other algorithm.